this video we are going to study about Acyloin condensation mechanism. This is very important name reaction. So let's study it now. See here, the reactant used here is carboxylic acid ester and the catalyst is metallic sodium, and the product we will get is alpha hydroxy ketones, which are also called as acylons. So here reactant is carboxylic acid ester. So it is having the general formula COOR. So it is the carboxylic acid ester. So the catalyst is sodium, which is in the metallic form, and the product we are getting is alpha hydroxy ketones, which are also called as acylons. So here alpha hydroxy ketones. So here it is a carbonyl group, and beside this the first carbon is called as alpha carbon. For this alpha carbon hydroxy is attached, that is hydroxy group is attached, so it is called as alpha hydroxy ketones. It is a ketone, so it is called as alpha hydroxy ketone, product of Acyloin condensation. So let's study the definition very clearly. So here, when carboxylic acid esters, as you know it is the carboxylic acid ester, when refluxed with metallic sodium, so when this carboxylic acid ester is refluxed with metallic sodium in the aprotic solvents such as ether, benzene, toluene and xylene. So here we will use aprotic solvents, so then we will get alpha hydroxy ketones, which are also called as acylons. So it is Acyloin condensation. So here why are we using this aprotic solvents only, why not protic solvents? So before that we have to know what is what are aprotic solvents. So these solvents do not contain OH and NH bonds, and they cannot form hydrogen bonding themselves. So here if we use protic solvents in this Acyloin condensation means, then using protic solvents results in the Bouillon blank reduction. So the another name reaction takes place if we take protic solvents in the place of aprotic solvents. So the aprotic solvent must be used in this Acyloin condensation. So let's study about the general reaction of this Acyloin condensation. So as you can see, here is a carboxylic acid ester COOR. It is a carboxylic acid ester. Here they have taken 2 molar of this carboxylic acid ester and reacted in the presence of metallic sodium, xylene or toluene. These are aprotic solvents. So then we will get a diketone intermediate. So here this diketone intermediate is very important in this Acyloin condensation. Then with 2Na we will get this type of product, and further when we react with acetic acid we will get acylon. So you will understand this general reaction when you come to know about the mechanism very clearly. So let's study the mechanism now. One thing you have to remember is, here is a formation of diketone before the formation of acylon. Here the reaction occurs in the 5 steps. Let's study it now. As you can see, here is the 2 moles of carboxylic acid ester. So here is 1 and here is 1. As you can see here, RCOR, and here is also RCOOR. So here the first step is, it is a step 1. What happens here? The transfer of electrons of metallic sodium to the carbonyl carbon. So here is the carbonyl carbon. See, double bond O is the carbonyl carbon. Here what happens means transfer of electrons of metallic sodium to the carbonyl carbon. We know that this sodium is having a electron, and this sodium is a metal and it has a tendency to donate its electron. So this electron is donated to the carbonyl carbon. This is the first step. So when here we have taken 2 Na, so here is a Na and here is a electron. So here the electron is transferred towards a carbonyl carbon. So here this electron is shifted to the carbonyl carbon, and here is a double bond. One of the bond is shifted to the oxygen. Here also same thing happens. Here is a electron and it has a tendency to donate electron. Why? Because it is a metal and this electron is shifted towards this carbonyl carbon, and here one of the bond is shifted towards the oxygen. So here first step is completed. that is transfer of electrons of metallic sodium to the carbonyl carbon. So here you are getting the product. So I have transferred the electron to this carbonyl carbon and this electron to the carbonyl carbon. So here the transfer of electron, I have mentioned electrons here, one on this carbon and one on this carbon, and here is a product of the first step. See, this R and C, and here is a single bond O. Why? Because one of the bond is shifted towards the oxygen, to the oxygen. So here oxygen is getting minus charge and it is minus, so we have added this Na plus here, and here OC2H5, and in another carboxylic acid ester group also here same thing happens. Here I have written the electron of this sodium and this oxygen is getting negative charge and I have added Na plus here. So it is the product of the first step. So now the second step is dimerization. So first of all we have to know what is this dimerization. Dimerization is nothing but it is an addition reaction in which two molecules of a same compound react with each other to give the adduct. So it is the same as below one. As you can observe, both are same. So when these are combined, it forms a adduct. So it is called as dimerization. So here is an electron and here is an electron. So if these two electrons combine means it will form a bond. So exactly same thing happens in this dimerization. As you can see, I have written the bond in the place of electrons. I have combined these two electrons and have written a bond. So here is our product in the second step. And now coming to the third step. In third step what happens means loss of both alkoxy groups. And you have to remember what is alkoxy group means. RO group. RO minus group. Here we know that this oxygen is having minus charge and this is having positive charge. Whereas this oxygen is also having minus charge and this sodium is having positive charge. When this is shifted towards this side and then it will become bond, and when this negative charge is shifted towards this bond it will become a bond. So here loss of both alkoxy groups takes place. 2C2H5 O Na group. So here alkoxy means RO minus. So here C2H5 O minus and I have added Na plus. Here is an Na and here is an Na. So it will become 2Na. So 2Na and 2C2H5O minus. So here both the alkoxy groups get eliminated. So here OC2H5, OC2H5 and Na plus, and this negative charge is converted as a bond. So as you can see in the next step, it is the diketone intermediate. Here is a ketone and here is also a ketone. So diketone, it is the diketone. So this group is also get lost. So here is elimination of both the alkoxy groups takes place. Here we have got a diketone. Next, in the next step what happens means it is a very important step. Then again reduction occurs in the diketone with the help of sodium salt. Then we will get indiol. Here why I have mentioned it as reduction means here the transfer of electron takes place. That is gaining of electrons is reduction. So here this electron is taken by this carbonyl group and this electron of this sodium is taken by this carbonyl group. So the reduction which gives sodium salt of indiol. As you know, this electron is shifted towards this carbonyl carbon and this electron is shifted towards this carbonyl carbon, and this bond is shifted to the oxygen and this bond is shifted to the oxygen. We will get the product like this. As you can see here, R single bond C and single bond O minus, and I have added Na plus, and the electron is transferred here, and here R single bond C and another electron is transferred for this carbonyl carbon, and the one of the bond is shifted to the oxygen. Then we will get this type of product. And again, as you can observe here are both the electrons are present. When this combine, we will get a bond. So I have converted this electron to a bond here. So when this is treated with acetic acid, then this Na plus gets replaced with this H plus. So here is one of the H plus gets replaced with Na plus, and this another H will get replaced with this Na plus. So here in the place of Na we will get H. So what will be the product? RCOH or COH. So the product we have got is enediol. Why it is enediol means here is a alkene, so it is en, and two diol groups, that is two alcohols. So it is one alcohol and it is second one. So these are diol, enediol group. So when this undergoes tautomerism, then we will get Acyloin, which is also called as alpha hydroxy ketone. So what is tautomerism means? These are interconvertible structures. Here the relocation of hydrogen atom takes place. Here observe it carefully. This hydrogen is shifted and it is becoming a bond, and this hydrogen bond is shifted towards the carbon and it will become a hydrogen. To understand it, let's write the last product. So here is RC and I have shifted this hydrogen to this bond. So here we are getting double bond and an oxygen. Next, this bond is shifted towards carbon. So I have written here single bond, and here is RC, and to this I have attached H. What happened here? This relocation of this hydrogen atom from this place to this third position has happened. So it is tautomerism, and it is the OH. As you can see here, it is the carbonyl group. For this it is the alpha position. For the alpha position there is a hydroxy group. So it is alpha hydroxy ketone, which is also called as Acyloin. This is about the Acyloin condensation. And you have to remember that small traces of oxygen will reduce the heat. So hence this reaction is carried out in the atmosphere of oxygen free nitrogen. This is very important. Thank you for watching.